Hello everyone, welcome to this advanced webinar on applications of GPM iMerge reanalysis for assessing extreme dry and wet periods. iMerge here is integrated multi-satellite retrievals for global precipitation measurements or GPM. My name is Amita Mehta and I will be conducting this webinar along with my colleague Sean McCartney. Overall objectives of this advanced webinar are learn to access iMerge data and derive regional precipitation statistics, that is mean standard deviation, anomalies which is departure from mean, and percentile values of precipitation. All these are useful for deciding dry and wet episodes regionally as well as locally. And further objective is to learn to calculate and interpret the standardized precipitation index or SPI using iMerge, and that also helps in assessing extreme dry and wet periods. So there are multiple ways to look at precipitation statistics, and that is the focus of this webinar. There are 3 sessions. This is the overall outline for this webinar. Today we are going to calculate precipitation statistics using iMerge. And so the way it is planned is that today you will be using web-based tools to access precipitation as well as to some calculations, and then use QGIS, which is open source geospatial information system, to calculate some statistics. So there is no explicit programming needed here. You will be able to calculate statistics just by using graphical user interface and web tools. Next week, then, we will focus on using scripts, and they will be provided by Sean McCartney to calculate SPI, again based on iMerge. And in both these weeks, we will have hands-on exercises that you can conduct to learn to follow the procedures and learn how to use the data and calculate statistics. Then the last session on February 4th will be focusing more on how to assess flood and drought risk, in which you use the statistics that we calculate in these first 2 sessions and then combine it with some additional socioeconomic data to see can we assess risk of flood and drought in a given region. Not only that, the last session will be mostly hands-on exercise where the participants, you will be conducting hands-on exercises that we provide instructions about. So here are the prerequisites for this webinar series. If you have not gone through some of these information provided here, we recommend that you go through this between now and next week just to be able to keep up with whatever is going on in this series. First of all, fundamentals of remote sensing. That's an online presentation as well as a video that you can view to learn about jargons about remote sensing. More importantly, here is a webinar, and there are also slides associated with them, overview and applications of iMerge long-term precipitation data products. It's crucial that you know details about the data sets. Since this is more advanced webinar, we assume that you have basic information about iMerge, and RSET also has conducted several webinars in which we have talked about iMerge. What is special about this particular data set is that it is now long-term, almost about 20 years long. And the important part is how to access this, how to work with this data to look at interannual variability in dry and wet episodes. In addition, to be able to access data and to analyze data, these some of the software and information is required. First of all, you have to register on NASA Earth Data to be able to download data. So here's the link where you can go on and register. It's free, but you have to have a username and password. Also, there has to be QGIS installed on your computer so that you can do the exercise. Panoply, this is also a software available from NASA GIS. This has to be installed on your computer to be able to do analysis, and this is for week 2. Also, Anaconda Python version 3.7, again, websites are given everywhere. You need to install that on your computer because you will be using Python scripts to calculate a standardized precipitation index. And for Windows users only, you need to install Git Bash, and again, website is given here. So these are all the prerequisites. So training format overall is given here. We have 3 sessions, as I mentioned. Each of them is 2 hours long. Not only that, we have 2 identical sessions in the AM and PM so that we can cover all time zones. Each session will have 2 parts. So first part is going to be presentations and demonstrations in which we talk about the data sets, about procedure, about how to access data, and then demonstration will be walking through how to use this data to calculate statistics or SPI. And then the second part, which would be a lab time, in which you will do a computer-based exercise on your own. We will stay online, so it will be about an hour long or a little more longer exercise that you can stay here and do. If you have any questions, we will be here to help you. If you cannot finish this in the given time, then you have this week to complete that exercise. And the exercises, they're already available from this portal, as well as they're available from the website, the webinar website, RSET website. After each week or each session, you will have homework assignments posted online, again, on the webinar website. And so there will be 3 homeworks, and the due dates for each one is like 11th, 18th, and 25th of February. So for example, the homework that you receive today is due on 11th of February, and so on. If those of you who attend all these sessions live and complete the homeworks will receive certificate of completion, and they will be awarded in about 2 months after the webinar series is over, and you will receive the certificates from Marina Martins. Her email address is given here. So here is today's outline. We'll have a brief introduction of RSET. We'll talk about RSET. And then again, we will have a very brief description of iMerge, data and access information. Again, as I mentioned earlier, the prerequisite webinar already has this information in details, but we will just learn enough for now to start the process. Then we will have a demonstration of a case study and calculations of precipitation statistics. Today, we will be using web-based tools in QGIS to do so, and we will focus on state of Texas, and that's the region we're going to focus on, for example, and then we'll then go to a local scale, like city of Houston. So can we understand how precipitation changed entirely over the state and then over the city, and how can you identify dry and wet periods based on precipitation statistics? So what we're going to do is we're going to look at long-term mean precipitation map. We will have time series of precipitation and percentile value of precipitation based on which you can see how heavy it is compared to mean. And then we will also calculate precipitation anomalies, which is departure from mean precipitation. So is it drier than normal or wetter than normal? And the exercise that you will be conducting will be identical, but you will use the area given here. So you will look at country of Mozambique and then focus on city of Maputo, which is the capital city for Mozambique. So we will have a demonstration, and then you will repeat the procedure on Mozambique and Maputo so that you get experience in using iMerge data and calculating precipitation statistics. So we'll start with introduction to RSET. NASA's Applied Remote Sensing Training Program, or RSET, it's a part of NASA's Applied Sciences Capacity Building Program. And as you can see on this side, the topics of training, they include water resources, air quality, eco and land systems, and disasters. And the goal here is to empower global community through remote sensing training. And our goal is to increase the use of earth science in decision making through training for policymakers, environmental managers, and other professionals, both in public and private sectors. As you can see here, RSET's now a little more than 10 years old and has conducted 130 plus training, trained 30,000 plus participants in 165 plus countries, and have reached more than 8,200 organizations. As you can see from these bubbles, different trainings have grown over the years. And RSET has a website which has a listserv that you can join to stay in touch with upcoming activities. Also, all the information about this webinar, all the slides, all the homeworks, all the demonstration, and exercises that you will be conducting, they're all available from this website. So next, we will have a brief introduction about iMerge data and access. So iMerge, which is based on GPM satellite, Global Precipitation Measurement Mission, is shown here. It was launched in 2014, February, in non-polar orbit. And as you can see, this goes from 65 south to 65 north, the blue orbits. If you see here, TRIM satellite, which was a predecessor of GPM, covered only 35 south to 35 north. And so GPM kind of follows TRIM, but it enhances and expands the domain that TRIM covered. And the sensors included in GPM are GPM microwave imager or GMI and dual precipitation radar or DPR. So GPM has products based on GMI and DPR individual as well as combined GMI and DPR. But as the name suggests, the multi-satellite analysis or iMerge, which uses not just GPM data, but it uses a constellation of satellites shown here. And overall, there are like 5 polar orbiting microwave imagers and also 5 sounders. They are included in this constellation satellites. They're all used to produce iMerge, and that really increases both spatial and temporal coverage and frequency of precipitation available, not just from GPM, but now the combination of these constellation satellites. So input precipitation estimates use a number of algorithms, and again, prerequisite has detail about this. This is based on Dr. George Hoffman's presentation and webinar, and he is the data producer, and then he describes each and every step, each and every algorithm. So basically, this is the imager algorithm, sounder algorithm. There is also a cloud classification scheme. Then main calibration is done through radar radiometer combined algorithm or CORA. And then finally, there is Global Precipitation Climatology project, which has been going on since 1980. Monthly satellite gauge data, they are used also as in calibration for this product. iMerge is at version 6 now, and they have multiple data sets as shown here. There is early version, late version, and final version. They have latencies, the 4 hours, 14 hours, and 3 months respectively, and then they have different purposes. For flash flooding, early. For crop forecasting example, it's late. And then finally is more research quality product because that is combination of satellite as well as gauge data. It's calibrated with drain gauge data over land. The data resolution is 0.1 degree. It's a global grid. And so although precipitation from GPM is available 60 south, 60 north, there are other satellites that are combined and morphing is used to get global precipitation. And as mentioned earlier, TRIM GPM combined algorithm is used as calibrator. So TRIM, which flew from 2000, actually it was launched in 97, but the data here covers June 2000 to May 2014 from TRIM and GPM after that. So now this is a one long combined record. Earlier we used to have two records, one from TRIM, which was 98 onwards, and then GPM, which was 2014 onwards. Now they're all calibrated, and so that we have one long time series. And those of you who use precipitation to look at water resources or look at climate variability, you know that longer the time series, better it is to trust the data and do analysis and come up with decision-making criteria. And finally, again, it is adjusted with GPCP climatology, as shown here too, to remove biases in the data. iMerge has been used for many applications, as you can see, from ecology, for water and agriculture, energy, disasters, health, and weather. And you can get more information from GPM application training site about these different applications. We're going to focus on drought and flood based on precipitation, long-term precipitation analysis. So iMerge data access that's shown here. Again, here is a link where there are step-by-step tutorials available how to download iMerge data. And there are multiple ways to look at or download iMerge data. There is direct FTP. There are special websites where you can do level 2 visualization and level 3 visualization and download. What we are going to do is we're going to use these two features. Giovanni, which is a website that we have often talked in our set webinars and which is widely used to access, analyze, and visualize data, as well as we're going to have direct FTP also from Goddard Data Information System. So today we're going to focus on using Giovanni, and then next week it will be using disk to use FTP to download data. So with that, what we're going to do is we're going to have a demonstration now in which we're going to take iMerge precipitation using Giovanni. This is the site. Then we'll calculate long-term mean precipitation maps for Texas. We will also calculate area averaged monthly precipitation time series for about 20-year period. Then using QGIS, we will calculate precipitation anomalies, as well as we will look at standard deviation of precipitation and see how we can look at dry and wet areas within Texas. Finally, we'll focus on Houston, city of Houston, where we will learn to calculate mean standard deviation, anomalies, and percentile values over the city, and that helps in deciding thresholds for dry and wet episodes. So with that, we will move to a demonstration. And then after the demonstration ends, you will be going through the same procedure. You have downloaded this procedure from the website or from this Adobe portal, and then or GoToMeeting portal, and then you can calculate precipitation statistics for Mozambique and city of Maputo. So we'll start with a demonstration. So next, we're going to have a demonstration of how to download, access, and analyze iMerge precipitation data using Giovanni, which is a web tool, and then learn to find regional and local precipitation statistics using open source GIS and Excel. So here we have picked a case study, which is the state of Texas, and for region and for local area, we're going to focus on the city of Houston and see how to calculate different statistical parameters using both Giovanni and GIS and Excel. Following this demonstration, there will be an exercise that you will be conducting, which will follow the same procedure and same steps, but you will be focusing on the country of Mozambique and then within that country, city of Maputo, to find out precipitation statistics. So we've picked these two regions, because both have interannual variability of precipitation with dry and wet events, both are affected by tropical cyclones and hurricanes, which cause flooding in many seasons over these two regions. So that's why we've picked these two for demonstration and exercise. In the last session, then you will have a chance to do the similar exercise for the area of your interest. So first we're going to start with Giovanni and see first of all how to derive precipitation long-term mean maps over the state of Texas. So this is the Giovanni web tool. As you can see, there is a keyword search for data here, or you can search variables from this left-hand side menu as well through disciplines, observations, measurements, platforms, etc. Here are the analysis options. You can have maps of data, comparison of two data sets, vertical profile, time series, and some miscellaneous parameters are there as well. Here is the temporal selection with year, month, date, and here you have spatial selection. You can either choose by drawing a box here on the map, or you can choose by entering a predefined shapefile, which is what we're going to use for Texas. So we'll start with iMerge, and we are going to pick iMerge Final. This is the data set, which is research quality data set and calibrated with rain gauges over land. So that's what we're going to use for this demonstration study. If you look at different data sets, you can see that it's monthly, daily, half-hourly. We are going to use monthly. This is merged satellite gauge precipitation estimates, final run, recommended for general use. This is latest version 6, and we're going to pick that. As you can see, the extent of data is from 2000 June to 2019 September. Also, we are going to change units to millimeter per month, because what we are going to do first is look at long-term mean for different seasons, and for that we're going to have units in millimeter per month. We're going to choose maps as monthly and seasonal averages. Once you choose that, a window will open. You can choose seasons here. December, January, February, March, April, May, June, July, August, and September, October, November. So we've chosen these seasons. We're going to find mean for each season for 2000 to 2019. So this mean provides a good reference precipitation, sort of climatology. This is about 20 years, but compared to that, you can look at departure of precipitation in individual year or find anomalies, and then that tells you whether it's a wet year or dry year or particular area is experiencing drought or flooding. Then we're going to pick Texas as our shape here. Once you choose Texas shapefile, you will see this is highlighted here. You can zoom in and pan the data if you want to, but here's the region that we're going to look at. Once you choose all these parameters, you can then go to plot data. For saving time, I've already plotted the data, but once you click here, you will see workflow, and then eventually you will get results, which we already have here. So these are monthly and seasonal averages, and plots are already here. So if you start from top, this is December, January, February 2000 to 2019. This is the extent of the data, and as you can see, all the maps are here. We are going to analyze these maps in QGIS. So for now, what we're going to do is see how to actually download these data. So for that, you can go down here on the left hand side and click on downloads. All the seasonal data are available in multiple formats here. You have netcdf files, you have PNG images, GeoTIFF images, and KMZ files, which you can view using Google Earth. So what we are going to do is download GeoTIFF files, all 4 of them. So these are long-term mean, all 4 seasons, winter, spring, summer, and autumn or fall. I have already downloaded. All you have to do is click on the file and save on your computer. For simplicity, you can give a shorter name such as iMerge mean Texas, or you can define a name that is shorter than this Giovanni descriptive name. That's what I have done, and I've saved all these files that we will eventually see in QGIS to analyze the data. But this provides you long-term mean. Spatially and temporally subsetted data can be used this way in Giovanni, so that you don't have to download the data. You can just download the final result as shown here, long-term mean, that you can analyze in GIS. Download these GeoTIFF files. You can go back to data selection for some more analysis. Next, what we're going to do is we're going to look at time series. So we are going to look at long-term time series for 4 seasons averaged over the state of Texas. Once you select all the parameters, you can again plot data, and then I've already done so to save time. And so we're going to look at the result. We're going to look at the time series that I got. This is seasonal time series. The plot here shows interannual variability of precipitation for 4 seasons over last 20 years or so. As you can see, M&M, or March, April, May, June, July, August, September, October, November generally have much higher rainfall than December, January, and February. In many years, June, July, August have more rain. Sometimes it's March, April, May, or sometimes it's September, October, November. So you can see that seasonally and interannually rainfall is varying. So it is good to look at seasonal rainfall and anomalies so you can identify which seasonally you can identify wet and dry period. And so based on this, for example, what I've done is picked June, July, and August season for detailed studies using QGIS, partly because it is one of the higher precipitation seasons, and it is the crop growing season also, the summer season. So for example, we're going to look at June, July, August, but you can look at all seasons and follow the same procedure for all 4 seasons. So this is, once you have the time series, you can download image by clicking here, or you can download the data. You can download this data as CSV file, as shown here. You can also have this netcdf file for all seasons as well. So there are multiple options. Once you have that, and we've decided that we're going to focus for the demonstration purpose on June, July, and August, we are going to find mean precipitation for each individual year. So again, you can go back to data. And now what you're going to do is again go back to map, monthly and seasonal averages. Everything else remains the same. Now we are going to find seasonal mean precipitation, and for now I'm just going to pick June, July, and August, but for your case study you can do all 4 seasons. Here we're going to just go 1 year at a time. So this is going to find seasonal precipitation for 2000. You can again plot data, then you will get a map of June, July, August for 2000, and I can give you some examples here. So monthly and seasonal averages. So this one is for 2001, June to August. So in that case, you go individual year, you can pick here 2001 to 1, 2 to 2. Similarly, I've done all 19 years. So I have 19 maps. So I have mean map for June, July, August, and I have 19 individual seasons from 2000 to 2019. I've saved them all, and these we're going to analyze in QGIS to look at statistics. Especially we're going to look at anomalies of this precipitation and standard deviation of this precipitation over this time interannual period. So I'm going to stop using Giovanni and go to QGIS. So this is the QGIS window. I have already loaded some data into this QGIS project, but we're just going to walk through the procedure and you will also be doing the same steps. So first of all, you can see this background map here. I've added this after opening QGIS and starting the project, either new project, or if you already have one, you can open the existing one and you can add a background map. I have used Quick Map Services, OpenStreetMap, OpenStreet Standard Map. That's what is shown here. You can use other options if you like. If you do not find this Quick Map Services plugin here, you will have to go to Plugins, Manage and Install Plugins, find Quick Map Services and install it. And this procedure is given in exercise 1. Once you have the background map, you can add shapefile. Here is, I already have downloaded this shapefile, so you can go to vector layer, add vector layer option, and navigate to your computer where you have all the files, shapefiles. So here I have shapefile from this is, I believe, from USGS. It's Texas state shapefile. I have picked a particular shapefile, open, and then add, and that's what's shown here. So you can see it here. You can zoom to this layer now so that we can see this zoom in version. These different areas are counties in the state. Similarly, I have added City of Houston metropolitan area with 13 counties and City of Houston. So this is the city limit, and then there are surrounding counties. So we can find precipitation statistics on all these areas, starting from state level all the way to this city level. That's what we're going to do next. So as we downloaded seasonal mean data from Giovanni, that's what we want to get in here, which I've already added. These are the raster layers. For that, you would go to Add Raster and navigate to the Giovanni TIFF files, the GeoTIFF files that you saved. So here I have saved as iMerge Texas, March, April, May, September, October, November, December, January, February, and June, July, August. And just by clicking on it, open, you can add, and that loads raster in the project. That's what we have here. So we have all 4 seasons. Let's start with December, January, February. So when you add the raster, it usually adds as black and white raster, but as you can see here, I have added a color table. By clicking this, you can see that, and I'm just going to show this one layer. You can go to Properties, Symbology. You would go to Render Type, Single Band Pseudo Color. Then you can either select minimum or maximum values, or you can leave default, like in some cases I have default here. Here I have fixed 10 millimeter per month to 210 millimeters per month, and for all 4 seasons I'm using the same color table so we can intercompare all the seasons, how precipitation varies. Here interpolation is linear, color ramp, there are several options. What we've chosen here is red, yellow, and blue, so that blue is the higher precipitation. Look, have fixed equal interval to 11, and so these are the values at every 20 millimeters per month. And then click OK, then the color table is loaded in the raster. One more thing is the transparency of the raster layer. Here it's 50% transparent. So once you set the transparency, you can see underneath. If you don't have a transparent layer, you will not be able to see what's underneath. But if its layer is transparent, then you can see the city names and the map underneath. So that's your choice, but it depends on the analysis that you're doing. But this is December, January, February. One thing to note is that here in eastern part there is more rainfall. As you go west, rainfall decreases. And when you go to March, April, May, as you can see that more and more in the central Texas also there is more rain now compared to December, January, February. When you go to June, July, August, not only precipitation values increase, now you have this coastal area where you have much higher precipitation, more than 200 millimeters per month. And similar pattern is there that as you go westward, precipitation is going down. For September, October, November, pattern is pretty much the same. You have much more rainfall in coastal region as well as in eastern part. Some moderate rainfall in central Texas, and then it decreases as you go westward. So this is the general mean seasonal pattern that we find. And let's keep June, July, and August because that's what we're going to focus on. So what we want to see now, these are the mean maps. Individual season is not going to look like this. It is going to be either more or less in certain regions, and that's what we want to see, how it varies, and that tells you whether its rainfall is deficit or excess for a particular season compared to long-term mean. But before we do that, there's one more parameter that we can look at, and that is standard deviation of precipitation. So standard deviation is just a measure of variability within this period. So around this mean, how much variability is there, that's what it tells us. And to find map of standard deviation, so finding variability at each grid point, we can use a routine, and we are going to use a grass routine for that. So in QGIS window, you can go to this processing toolbox and type grass. A number of routines will appear from which you can choose R.series. This has many statistical parameters that you can find from a time series of raster. And for that, once this window, R-series window opens, you can choose the input raster layers. So when you click on that, all the rasters that you have loaded in your project, they show up. And we are going to use the seasonal June, July, August mean for each and every year from 2000 to 2019. You can select and you can then add by clicking OK, and it shows that 20 elements are selected. Also, you want to have propagate null, you pick that. Aggregate options are shown here. These are all the statistical parameters you can calculate. We already have average from Giovanni that we just saw, so let's not have that. We are looking at standard deviation, but you can look at range like minimum and maximum. So for in the 20-year period, what was the minimum and maximum value of precipitation? Accumulated precipitation, variance, different moments, you can find all this, but we are going to look at standard deviation. You can leave, rest of the parameters can leave as options. One thing though, for minimum and maximum value, you may want to set it to a certain value. Sometimes if there are undefined values, you certainly don't want to include them in the calculation. So you can set a range which you know is valid for precipitation for your data. And this is a good range. So after setting that, now this is going to save this to a temporary file. Once you set this, you can run. And okay, you will get a map of standard deviation once this is completed. And so this layer is added here as aggregated air layer, and value shown here, like minimum is 10.5 millimeters per month to about 84.4 millimeters per month. I have actually used and renamed this as standard deviation June, July, August, and I have added color table to it. So these are the values we just saw. So again, you can see that where there is in June, July, August, we saw that much larger rainfall in eastern part and also in coastal Texas. That's where more variability is there too. So almost, if you say 200 millimeter is the mean, then 85 it is almost 25% variability over. So in 20-year period that we looked at, rainfall has varied about 25% in this region. You can say that. So that's how standard deviation helps you look at overall variability. Now we are going to look at individual years, how each year varies, what it shows compared to mean, and for that we have calculated anomalies. So anomalies is nothing but just departure from mean, and to calculate that, what we would do is go to raster calculator. Before that though, all these individual seasons are loaded in your QGIS project. So just add raster, and all these files we save from Giovanni. So mean, June, July, August precipitation for each year. Now go to raster calculator. When you click on it, you have this operators window. You can see that all the rasters that you have in your project are also listed in here, and you can define or give a name. So say here is anomaly 2000, and you can say save. And now the operation would be, now you find 2000 June, July, August IMERGE precipitation minus, it's the mean 20-year mean precipitation for June, July, and August. Once you complete this operation, you will get numbers which are either positive or negative. So positive precipitation means 2000 season had more rainfall compared to the mean, and when it is negative, that means 2000 had less or deficit of rainfall compared to mean. And that's what has been calculated in these anomalies here. So this is now anomaly of 2000. I've done same for 2001 to 2019. That means take individual season and subtract the long-term mean for that season, and that gives you anomaly. For here, I have set color table to minus 50 to 50 millimeters per month. This is there are some values which are outside, but these are the typical values. Also, you can see that minus 10 to 10 millimeters per month around the mean is white. So this is near normal rainfall, let's say. When you go to red and blue here, they show deficit and excess compared to long-term mean. So if you look at anomalies for 2000, you can see this special pattern in which eastern part has deficit of rainfall, especially near coastal region. It's minus 50 millimeters per month or even lower. I have kept the same color table for all years so we can compare them. Let's just turn them on now and look at each year very quickly to see how precipitation, deficit, and excess vary with year. So we saw now this is 2001. So 2000 had deficit, where here you have excess of rainfall and deficit over this part. 2002, again you can see a lot more rain in the central Texas. 2003, 2004, entire state had about normal rainfall. 5, 2006, the central Texas had deficit of rainfall. 2007 again had much wetter in this part, just a little bit of drier in the northern part of the state. So year after year, June, July, August shows this variability. Now this is based on iMerge. Here there is deficit, here there is excess of rainfall. 9 again there is deficit, now 10. 11, this was a major drought in Texas, and it shows that anomalies are all negative here. Similarly, 12 also was more or less a drought year, and that's so both 11 and 12. Now 2013, also eastern part had deficit of rainfall. So all 3 years, 11, 12, and 13, there was more or less rainfall. 14, then also in certain part there is recovery, but there are also parts where there is drought-like condition. 15, 16 then has more rain, and 17, this was Hurricane Harvey. So June, July, August. August had very heavy rainfall, and that sort of shows in this region. So anomalies clearly show which areas of the state had normal rain, more rain, or less rain. And as you can see, there is quite a lot of variability. And once you have this long precipitation period, and if you keep tracking anomalies, you can then strategize how to deal with either deficit or excess of rainfall. So that was at state level. What we saw was long-term mean standard deviation and anomalies. If we are interested in local region to look at time series over, say, one city, and in this case we can look at city of Houston, how would we do that in QGIS? If you were to do that in Giovanni, you can pick a smaller domain, but you cannot have like small shapefile. There are predefined shapefiles in Giovanni. So either you have to go to the smallest level like one grid point, or you have to just use predefined shapefiles. If you have smaller region that you're interested in at county level, or even at roads or other infrastructure level, then you can use QGIS. You can extract time series and do statistics at that level. And that's what we are going to see now. For that, we have two Python scripts. One that works with mean seasonal precipitation, so time series of each seasonal year, with this each year the seasonal precipitation, and second Python script works with anomalies. So by running this Python script, what you can do is extract time series and statistics at region within these polygons. So we are going to start with these 13 counties, and then we'll pick Harris County, which is here where the Houston city limit is. So that is what we are going to do. We have these two Python scripts, and these are available for Mozambique in your exercise. The files that you downloaded today should have those. This is for Texas. So here, just quickly going through the script, it picks all the raster files which has iMerge string in it. So this is for mean precipitation, seasonal mean precipitation. And here that's the raster, and it takes this City of Houston counties as the input vector, or within that it finds statistics. And in here, stats, when it's 2, it finds mean. So you'll get mean precipitation within this polygon, so average within that polygon. And since there are 13 counties, we will have means for each county in that. So for that, what we do is actually, in your case, you will have, instead of COH here, this is Maputo. That's what you will have when you do exercise. Basically, just you will be copying the script and go to plugin Python console, and you can just paste. Here is where the run command. You can run this, and what it does is go through all the iMerge files, so all the mean files, and then you get time series, so mean precipitation within that polygon. And the way you can look at is, first of all, you can close this Python console, go to city of Houston counties, and go to attribute table. So when you open attribute table, you will see that you have 2000 mean, 2001 mean, 2 mean, and these are all 13 counties. You can see here all 13 counties. You can click on each ID and it highlights which county. If you go to 3, that is the county that has Houston city limit within this. And so we can look at that one, or you can look at all these counties. If you want entire metropolitan area, you would actually add these numbers and come up with one number, or take mean and get one number for each count for entire metropolitan area. Here you have county by county information for all years. You can do the same with anomalies, but let's work with this mean first. Once you have this attribute table, then you can save this file as a CSV file. And for that, you need a plugin. It's called MMQGIS. If you don't have this, then again, you can go to plugins and find it and install it. But here we have it, and you find import export, attributes export to CSV file. Once you have this window where it's export attributes, now you can pick all the files all the means that you have, 2000 to 2019 mean, and now you can save this as, let's keep this as temporary file. You can save this and give a name here, say COH counties or COH precipitation, and then you can apply. And when you apply, it says 13 records exported. It goes into this temp1 CSV file that we will look at later. Similarly, you can copy the second script, which is the anomaly script, anomaly zonal statistics. So basically what this uses, and I'll show it, raster zonal statistics. So here is what, again, within this, it gives anomaly, time series of anomalies, so mean anomalies. And just type similarly in Python console and you can get anomalies in CSV file by using MMQGIS. Basically what it does is, actually there is a routine, it's called zonal statistics. And in here, if you look at statistical calculation, here are all the calculations you have for that polygon, within that polygon. And we just use stats equals 2, so 0, 1, and 2, that's mean, but again you can have standard deviation and other statistical parameters as well. So this is the routine that is used in that script, but it just does automatically so that you don't have to do it raster by raster. So at the end of this procedure, now we have two CSV files that I want to share with you, which were created using zonal statistics function in the Python script. And using MQGIS, these files are saved as CSV files. This file is for City of Houston precipitation, mean precipitation, and you can see the top row shows years from 2000 to 2019, and then 13 numbers following that are the numbers for each county. So now you can average these numbers and then get one number for Houston metropolitan area, or you can do statistics county by county. For example, we are going to look at this county. In here, it's number 4. As we saw, this is the Harris County, for which within which City of Houston limit is there. And so, what we're going to do here is use this AutoSum function and find average. So this is the mean for all these years. Next, you can also find standard deviation, and for that you can use more functions here. There is standard deviation. If you don't see that, you can search by stdiv in this window, and then you can say insert function. Here, the actual time series is A4 to T4, and so this will be the standard deviation. When you say done, this is standard deviation. As you can see, this is almost like 65 millimeters per month, and that's the variability over this, indicates variability over this 20-year period. Next, we're going to find percentile value. So percentile values are, if we pick a 90 percentile value, then in the time series, all the values will be 90% of the values will be below this and 10% values above this particular number. And this helps us identify heavy precipitation events, so that the top 10% heaviest precipitation. So we're going to use percentile, and again you can type here if you don't find it in more function, then insert function, and it's A4 to T4 again, and for percentile number it is in fraction. So for 90% it is 0.9, and this is the number you get. So it is 199 millimeters per month. So 10% values within this record would be above 199 and 90% below. So those are the heaviest event. So this is the way you can find statistics for a local area based on time series. You can plot this as a line. This is just to visualize this. And as you can see, so this is about goes from 50 to almost 350, and 199, which would be 99 percentile value, it's somewhere here. And so actually you have one or two events about that. If you look at mean, it is 142 somewhere here, and on top of that, if you add 64 or below 64, that would be the range of standard deviation within which your rainfall would be there. So this allows you to, for the given time series, you can see the characteristics over that local area. And once you know that from the past data, you can expect, when you look at current data value, current precipitation value, you can quickly place it in this chart. Is it in top 10%? Is it, so you can find different percentile values and have a range within which current precipitation value will fall. And based on that, you can use that number or that information for planning for if there's going to be flooding in the city or so. So it can help in many ways, the statistics. So this is a simple way of doing statistics for one county. We can see this is the anomalies here. It's the same years, and then these are anomalies for each county. And for Harris County, I've plotted this here. Anomalies, as you can see, it's almost minus 60 to about 200. And this 2017 year is because of Hurricane Harvey. Over Houston, there was a lot of rain, and that's what it's indicating. But you can also see that there are years where you have positive anomalies, whereas there are periods where you have deficit of rainfall even within that city area. So looking at these parameters, you can, and looking at statistics also, you can come up with some kind of reference precipitation values which can help in decision making for either flood or drought or dry or wet events. So that's basically the demonstration for Texas and Houston. And this concludes our demonstration part. But what you will be doing is following the same procedure and do this analysis for Mozambique and also for the city of Maputo. So what we will do is we will stay online. You can work on the exercise. And if you have any questions, we will be online. And at the end of 1 hour now, after this, we can have question answer session if you like. If you cannot finish the exercise, you have still 1 or 2 days to finish that. Your homework is based on that. So you can finish the exercise and then attempt the homework 1. So I'm going to close this demonstration now, and you must have downloaded all the files. And again, we will also guide you through those exercises while you are working on it. So okay, thank you. Thank you, everyone. And you must have downloaded this exercise. It says calculation of precipitation statistics, case study in Maputo and Mozambique. And so the demonstration we saw, this is very similar, follows the same procedure for different region. And so you can go through this. What we will do is we will stay online. If you have any questions, you can type in the chat box, but basically it's your lab time to work on this. And first homework is based on this exercise, which is due on 11th of February. So actually, if you cannot finish everything today, you do have some time. Although it's not, it looks long. Once you start going through the steps, it should go very quickly. If you have any questions or if you get stuck, you can ask us now, or you can send email to either me or Sean McCartney, and you have email address given to you at the end of the exercise also. So we start with this exercise, and if you have any questions, please type in the chat box and we will try to address those. Okay, so we'll be online, and we recommend that you start this exercise now. Everything you need is available from ArtSet website also. You will see that you will be calculating number of statistics, and you will be creating number of files using Giovanni. But sometimes because of the internet speed, if you have difficulty in downloading and data, we already have provided this data for you to do GIS analysis. So you can download the data files. So seasonal mean precipitation and also anomalies, they are already given. Python scripts are given as well to find standard deviation, and so you can and to find the time series over the polygon. So please use those files. So you can of course download all the TIFF files, anomaly files, and CSV files, but the idea is for you to go through the steps so that you can download data, start from the beginning and go to end. So by all means, do download data, but do attempt all the steps. All the files, again, as I said earlier, can be found from the ArtSet website, and exercises are also available in handouts from this portal. And here is comment that can we see this section again, but actually, if you go through the procedure, it's all listed. So the steps, if you follow them, it's exactly what we did in the demonstration. And the idea is that you don't have to go back and see the demonstration, even in future, when you do it for other region, you can just follow these steps. There is a question here that someone has problem downloading the PDF file. It should be available from ASET website also. There is a question, comment here. Somebody, you're stuck with Python on part 3 exercise. Can you tell us what exactly the problem is? Did you copy the script? And did you paste in the Python console and run it? Do you get any errors? Yes, so for downloading data from Giovanni, you will have to log into Nasard's data. In Giovanni, if you go in map, you can go to select seasonal, monthly and seasonal, and that's where you find seasons. So that's where you will be logging in to Earth data. So here in monthly and seasonal averages, when you click that, I think it's slowing down because everybody is searching for the data. So when you go here, you will see seasons. Select seasonal data. You go here, you can find seasons. In maps, if you should have monthly and seasonal averages. In time series also, you should have seasonal averages. Once you choose select seasonal date, you should be able to pick start and end years. Okay, there's a question, can we import this product to hydrologic model? We'll talk about that later after the exercise is over. So once you go to plot data, and the workflow will start, and then you should go to you will see the plot on the same tab. If it is taking a long time to do that, at this point you can download data or use a zip file to get the files. There's a question, can you provide options to select in plot and date range? So here is, it's not very clear, but here is where there is date range. And here are all the plot options. The question here is, what was the base period for calculating anomalies? And yes, it was 2000 to 2019. The standard deviation tool is should be in on the graphs r dot series. So if you're having trouble downloading data or even plotting from Giovanni, please use the files from the zip file. All the files are given there. We realize that when several hundred people are trying to access the same data set on Giovanni at the same time, it slows down a bit or quite a lot. And so, just so that you don't get stuck, we have provided you all the files. So you go through all the steps, but if you don't get the data right away, please go ahead and use the data from the zip file. So you actually don't have to wait for downloading the data. It's good to just go through the steps so that next time, if you want to do the same exercise or same study for your own region or area of interest, then you know exactly what the steps should be. But please go ahead and use the data that we have provided. Once you go through the procedure, you don't have to wait to download the data. Once again, please do not wait for Giovanni plots or download data. Just go ahead and do the procedure, but use data from the zip file. One question here is, I have the data, but how to put it into QGIS? If you have the exercise with you, it shows step by step how you can add both vectors and rasters in the data. Mozambique shapefile is also available, as you must have seen from the website. So that you load as vector and precipitation as raster data. So in part 2, you will see how to put data into QGIS. To calculate standard deviation, we are just using the mean iMerge data seasonal each year, 2000 to 2019. Not the anomalies or nothing else, just the iMerge mean data or DJF in case of Mozambique. So the question is, you need to group the rasters. If you actually don't have to, because for standard deviation, at this point, it doesn't matter which order they are in, as long as it's like a continuous time series for 19 years. So, I mean, even if years are in different orders, you will still get the same answer. If there is some error in graph 7, it will be difficult for us to fix this because this may be related to your version of graphs and QGIS. So plugins are not provided in the zip file. Quick map services, you will have to search and find from QGIS plugins. There should be a .prj file for Mozambique in the zip file, I believe. In quick map services, there are several options. We just use OSM, OpenStreetMap, standard version. That's what we have used. So QGIS may be okay, maybe GRASS version is what you need to check for standard deviation routine. If you do not have GRASS in your QGIS, or if you're having trouble, you can try and figure out how to get it in GRASS, in QGIS, how to get GRASS in there. But if you don't get, that's fine. You will be able to go through the rest of the exercise because you have the data. If you get stuck on standard deviation, don't worry about it. You can move past, get the anomalies. So I think QGIS 2.18, it's an older version. All versions that this was tested on is through 3.6, 8, and 10. So those should work. So we have about 10 minutes. You can continue with the exercise. Also, if you cannot finish it now, that's okay. You have a few days to finish it. You can send us emails if you have any specific questions. Only thing we cannot really fix is if your Python version or Grass version or a QGIS version, they're different, then we really have no control of how to fix that. Other than that, you can send us questions and you can finish it before you complete your homework one, which is due on 11th of February. So if you cannot go through the whole exercise in next 10 minutes, that's okay. You can keep working on it. So even later, if you want to download data from Giovanni, and if it is slow, in the chat box, you have Giovanni beta version link available. You may be able to use that as well. We just have a few minutes left, so you can continue with the exercise later on in your own time. We can go to the question answer session. So question one, how is the base period for the mean calculated for the anomaly? So that is 2000 to 2019. Yes, that's correct. So we already went through question two, MNQGIS. Is there a way to separate the snow from GPM? Yes, actually, next week when we go through a download of data, there is a, along with the data itself, there is a parameter or there is a indicator that says probability of liquid precipitation. And so that tells you, so which, if the higher the probability, less the probability of liquid phase, then it is snow. And I will give you, if you go to, I'm giving you a link for iMerge detail so that you can go back and look at how they derive all the parameters in. So you will see the link in the chat box, which is about iMerge, how it is derived. And there you will see how the snow and rain are separated. So in Python on part 3, if you can tell us what the error is it because of the script or because the Python version, we wouldn't know. So if you can be more specific what error you get, we might be able to help. Okay, we went through where I can choose the seasonal part in Giovanni. And you can see it in the steps also. So basically in the time selection part, you will have in the map, last is monthly and seasonal. When you go for date selection, it will ask you for seasons. We had a demo of that. So question 6 is related to question 5. Once you click on the date range, it will ask you month or seasons. Question 7 is the same as question 5 and 6. Once you select in the map or time series and click on date range, you will see the option. Can we import the iMerge product, is question 8, into hydrologic model for further analysis? Yes, actually you can. And we have done that. If you go to our set webinar on WIC, and link for you here, that shows exactly how to use iMerge data. If you may, some older version may use trim data, but now this new iMerge data can be used exactly the same way. In which tab will I get plot? You should get to the plot once the data are plotted. It was just slow perhaps today. In which tab will I get plot? I just answered that. Once the plots are there, you will see them in the same tab. And then at the bottom right, you will have go back to data selection to go back to Giovanni main window. Question 10, can you provide options to select in plot the date range? Yes, in your time series, you can pick different dates, different years if you like, and that's what you will get in your plot. So in the time selection part, you can do that. Which tool is to be used for drought monitoring? So there's no one single tool. People have used different ways to look at drought. So anomalies can simply tell you deficit or excess of rainfall. Next week, we will calculate standardized precipitation index, which also shows drought and drought detection capability. This is mostly focusing on meteorological drought, but if you want to look at other types of drought like hydrologic and agricultural, then you have to look at soil moisture, groundwater, etc. And so there isn't one index for monitoring drought. It is depending on what time period you are interested in, what type of drought. But there is a site, I can give you US drought monitor is there. It has a lot of information. And you can go to droughts.gov. That also has quite a lot of information. Precipitation recovery technique. Yes, so for merge level 3 data that we have looked at, you can get either liquid precipitation or frozen precipitation. So probability of liquid and frozen. So if the data you will get in millimeters per month, but there is an additional flag in the data file which tells you probability of liquid precipitation. Higher it is, more it is rain. Lower it is, it could be more towards frozen precipitation. But drizzle, hail, these are not distinguished in there. For that, you can look at precipitation radar data, and that is something is given on the PMM website that we mentioned, Precipitation Measurement Mission website. You can get more information about that. If you look at precipitation radar data, actual precipitation radar data from GPM, that may have some information. Okay, so here, how to downscale iMerge data to 30 meter spatial resolution. So downscaling data is, precipitation data is really not as simple, but you can use something like terrain or land cover as a interpolator or as dependent variables to downscale precipitation. Yes, so question 14, zip files are only for DJF season. That's fine. For homework is also based just on that. There is a batch download, question 16. You will see that next week. To calculate seasonal standard deviation, in this you just use seasonal mean for each year. Those are the only 20 or 19 images, depending on what you're looking at. Those are the images you will pick. Just the seasonal mean precipitation for standard deviation. So that was question 17. So we see that there are more questions coming in. Since we have limited time, we will have to close the webinar room, but we will go through the questions and they will be posted on the website for your information. So thank you for attending today's session. Please send us email if you have any specific questions about the exercise and homework. We will go through your questions here, and you will see that on the website also. Next week, we will have calculation of standardized precipitation index based on iMerge data. So thanks again for attending today's session, and we hope to see you next week at the same time. And I want to thank everybody from the RSET team for helping here. Sean McCartney, my colleague who will be conducting the session next week, Selwyn Hudson-Odoi, Brock Blevins, and Jonathan O'Brien. They all helped in coordinating, editing, and putting this webinar series together. So thanks, everyone. Okay, so we have, part 2 is actually on Thursday, on 30th of January, not next week. Next week will be part 3. So on Thursday, we will see you for part 2. So again, I want to repeat, part 2 is on Thursday, the day after tomorrow. So please join us.